All right, let's dive into some cool science today. And I mean that literally because we're tackling the question of why ice is so slippery. You'd think that solid water would be, well, solid.
Yeah.
But we've all had that legs fly out from under us moment.
It is fascinating, isn't it? This everyday thing is a real head scratcher for scientists, even now. We
Now,
still haven't totally cracked the code on how slipperiness works at the molecular level.
really, it's that much of a mystery. I mean, I pulled those 5 factoids from that cocktail party chemistry episode, and some of them are already kind of blowing my mind, like that first one about a surface water layer. Is ice actually melting all the time, even when it's below freezing?
So their ice, this thin layer of liquid water on ice, even when it's way colder than the freezing point. But it's not just from pressure melting, which is what most people think. This layer is just a few molecules thick, and it forms because of how the water molecules bond at the surface. They're kind of like the edge pieces of a puzzle. They have fewer neighbors to hold on to compared to the molecules deeper inside, so they end up in this quasi-liquid state.
Okay, so like the top layer of the ice can't decide if it wants to be solid or liquid. I guess that makes sense in terms of slipperiness. But
Yeah.
what about when we're talking about ice skates? One factoid mentioned that pressure lowers the freezing point. Is that the secret to gliding across the rink?
Pressure is definitely a big part of how skating works.
Yeah.
But it's not quite as simple as just making a buttle under the blade. Those super thin blades concentrate all your weight onto a tiny, tiny area. And that creates enough pressure to melt the ice right there for a split second.
So we're basically surfing on a tiny puddle that's constantly melting and refreezing under our skates. That is so cool.
Exactly. It's this constant back and forth,
Yep.
melting and refreezing as the pressure shifts with each stride. If it was just a static puddle, skating wouldn't be nearly as smooth or effortless.
That's pretty mind-blowing. But then there's this super cold water thing that just makes my brain hurt. How can water stay liquid below freezing? I mean, shouldn't it just freeze?
This is where it gets really interesting. Under very specific conditions, you can actually cool water below its freezing point without it turning into ice. It's all about what are called nucleation points. Those are like tiny imperfections that ice crystals need to start growing.
Wait, so if the water is like super pure with absolutely nothing for ice crystals to latch onto, it just stays liquid, even if it's technically below zero. That sounds like something out of a magic show.
Exactly. It just shows that even something as familiar as water still has secrets.
Speaking of secrets, the last factoid was that scientists still haven't figured out exactly how slipperiness works. I thought we had this all figured out, like it was settled science.
It really shows how even things that seem simple can be incredibly complex. We've got a few different theories, each with some evidence to back it up. Some scientists focus on that quasi-liquid layer we talked about and say it reduces friction. Others think it's more about how water molecules vibrate on the surface of the ice.
So, even after all this time, slipping on ice is still a bit of a scientific mystery. So why should we even care about all these tiny details? Is it just bragging rights for scientists, or is there a bigger reason to understand slipperiness?
That's a great question. And it really highlights how important basic research is. Understanding how friction works on ice is a big deal for a lot of fields, not just winter sports, but things like climate science, too.
So it's not JID about avoiding a wipeout on the sidewalk. There's actually some serious real-world applications here.
Absolutely. Imagine designing better winter tires, safer roads, or more efficient icebreakers. It all comes back to understanding ice at a molecular level.
Okay, so this isn't just about science for science's sake. It's actually crucial for a lot of important stuff.
Exactly. And then there's the whole climate science angle. Think about massive glaciers and ice sheets. How easily they move and melt depends a lot on how slippery they are. And that has a huge impact on sea level rise. Plus, let's be honest, it's just plain cool to understand something we see almost every winter.
You've definitely made me look at ice in a whole new way. Who knew something so simple could be so scientifically complex?
That's the beauty of science, isn't it? There's always more to learn and explore, even in the everyday things.
Before we get too carried away, let's recap what we've learned about slippery ice so far. We've got that thin, quasi-liquid layer, kind of like a built-in lubricant.
And don't forget pressure melting, the reason we can glide on skates.
Right. And then there's supercooled water, which just proves that water is way more complicated than it seems at first glance.
Absolutely. And of course, scientists are still arguing about the exact details, which shows how much we still have to discover.
As we go through all of this, what part of this whole slippery ice thing has surprised you the most?
For me, it's the fact that scientists are still debating it. It shows how science is always evolving. and how even simple things can hold huge mysteries. What about you?
Honestly, I think the supercooled water thing blew my mind the most. It just doesn't seem possible that water could stay liquid below freezing.
Yeah, it's definitely a weird one.
I feel like we've only just started to understand this whole slippery ice thing. There's definitely a lot more to uncover. So we're going to continue our deep dives into the science of slippery ice right after this. Stick around.
Welcome back. Glad you stuck around. What's been on your mind since we last talked about slippery ice?
You know, it's funny, we've been getting into all this stuff about molecules,
Hmm.
but I can't help but wonder if the texture of the ice itself matters too. Like, is smooth ice slipperier than bumpy ice?
That's a great point. Slipperiness isn't just about what's happening at the microscopic level. The larger scale stuff definitely makes a difference too. Think about it. Is the ice smooth as glass? Or is it all rough and bumpy? Is there frost or snow on top? Those things all affect how slippery the ice feels.
Yeah, that makes sense. I mean, I'm sure trying to walk on jagged ice is a lot different than gliding on a smooth skating rink.
Exactly. And even a little bit of frost or snow can change things a lot. It's like adding tiny speed bumps that make it harder to slide.
That actually reminds me of something we talked about earlier. Scientists are still arguing about exactly why ice is slippery. If it was just about that quasi-liquid layer, wouldn't all ice be super slippery all the time, no matter what the surface is like?
You've hit on something important. The fact that slipperiness changes depending on things like temperature, pressure, and the surface. It all suggests that there's more to it than just that thin layer of water. Some researchers think the way the ice crystals themselves are arranged might also play a role.
Wait, so the ice crystals themselves could be making the ice slippery? How does that work?
Well, ice can form different crystal structures depending on how it freezes, and some structures might be inherently more slippery than others because of how their molecules are arranged and how they interact with other surfaces. It's kind of like how different fabrics feel different. Some are smooth and silky, others are rough and coarse.
So even though we all know what slippery ice feels like, there's still a lot we don't know about how it works at the most basic level. It's pretty cool that something so ordinary can still have mysteries.
I agree, that's what makes it so fascinating to study, but let's step back for a second. Besides just understanding the science, why should we care about slippery ice in the real world?
Yeah, that's a good question. I mean, besides wanting to avoid wiping out on the sidewalk, are there actual uses for all this knowledge about slippery ice?
Absolutely. Understanding ice friction is super important for a lot of different things. For example, engineers use it to design safer cars, airplanes, and ships, things that have to operate in icy conditions.
That makes sense. I can see how knowing how ice interacts with different materials would be important for things like winter tires or de-icing systems.
Exactly. And then there's cryogenics, which is the science of really, really low temperatures. Understanding how things behave at those temperatures, including ice, is crucial for developing new technologies.
Like what kind of technologies? Are we talking about futuristic stuff here?
Not quite science fiction, but definitely cutting edge stuff. Think about superconductors, which can conduct electricity with zero resistance. Those could completely change things like how we transmit energy and how we travel, and understanding how materials behave at super low temperatures, including ice, is really important for making progress in that area.
Wow, so studying something as basic as slippery ice could lead to some really big technological advances.
It just goes to show that even the most ordinary things can have a big impact when we take the time to really understand them.
I'm definitely feeling a lot more knowledgeable about ice now.
Yeah.
But is there anything else we should touch on before we wrap up our deep dive?
I think the biggest takeaway here is that even though we've learned a lot today, there's still so much we don't know about ice.
Like those questions about how slipperiness works at the molecular level
Yeah,
and how different ice crystal structures might be involved.
exactly. And that's what makes science so exciting. There's always another layer to peel back, another mystery to solve.
This has been a really eye-opening journey into the world of slippery ice. I
Yeah.
feel like we could talk about this stuff for hours, but sadly, we're running out of time. So what's one last thought you want to leave our listeners with?
The next time you see ice, whether you're carefully walking on a frozen sidewalk, or watching figure skaters glide across the rink, or just looking at the frost on your window,
Take a second to think about all the cool science that's happening right there.
think about those water molecules constantly moving on the surface, the way pressure and temperature affect things, and all the debates scientists have had about this seemingly simple substance.
And maybe it'll make you appreciate winter just a little bit more. Wow, I gotta say, After this deep dive into slippery ice, I'm looking at it with a whole new level of respect.
Yeah.
It's amazing how something so ordinary can be so fascinating when you really get into it.
It's true, isn't it? When you start digging into the science behind everyday things, it's like a whole new world opens up.
Absolutely. We started out wanting to know WHY ice is slippery, and we ended up learning about all sorts of things, that quasi-liquid layer, supercooled water.
Right. And even after all this time, scientists are still trying to figure out exactly how slipperiness works at the molecular level. It's a good reminder that there's always more to learn, even about the stuff we see every day.
You know, before we started this deep dive, I honestly thought ice was just kind of annoying. Something to avoid so I wouldn't slip and fall.
But now,
Now it's like this amazing material with all these hidden complexities. I feel like I've unlocked a whole new understanding of something I thought I knew.
that's the beauty of science, isn't it? It helps us see the world in a new way.
As we wrap things up, what's the one thing you hope our listeners will take away from our exploration of slippery ice?
I think the most important message is this: never stop asking why. Whether it's something simple like slippery ice or a big, complicated scientific mystery, that curiosity is what drives us to learn and understand the world around us.
I love that. Never stop questioning, never stop exploring, and never take the ordinary for granted.
Because even something as basic as ice can hold amazing secrets, just waiting to be uncovered.
That's a great note to end on. Thanks for joining us for another deep dive. We'll see you next time for more explorations into the fascinating world of science.